Okay, I'm going to go through the entire TP1 again. So if you need explanation for a certain portion that I already went through in class, you can listen now, or else you just fast forward to the last question. Okay, so for the MCQ, okay, answer is CDC. Okay, so how do you get the OS of vanadium in ammonium vanadate? Okay, so notice that the formula, if you balance out the charges, it will be NH4VO3. Okay, so you already know that NH4, the entire total oxidation state of NH4 is a +1, as well as VO3 is a -1. So actually all you have to do, okay, is look at VO3 minus. Okay, so you just let the OS of V be X. Okay, you have X plus 3 times O2, each O2 is -2, 3 times -2 equals to the total oxidation state of VO3, which is -1. Okay, and then you have X minus 6 equals -1. Okay, you bring over X equals -1 plus 6 equals +5. Okay, answer is C. Okay, next, which of the following mixtures produces ammonia when heated? The only reaction that you learned that produces ammonia is ammonium salt plus alkali, which gives you ammonia plus water plus salt. Okay, only this reaction that you have learned. I mean, apart from Haber process. Okay, so you need to identify ammonium salt. You need an alkali. Okay, alkali you learn. If you recall, you have like NaOH, KOH. Okay, aqueous ammonia. Okay, lithium hydroxide from your periodic table. Even your calcium hydroxide and barium hydroxide. Okay, so all these are a list of alkalis. So you just go down the list. Okay, A is wrong, there's no alkali. B is wrong, no alkali. C is wrong, so the answer is D. Okay, take note that D is your CH3C COONH4 actually is a ammonium salt. It's actually, okay, ethanol, ammonium ethanoate. Okay, then you have calcium hydroxide, so the answer is D. Okay, question 3, which of the following statements about the Haber process is incorrect? Okay, you just need to check which is correct, and then the remaining one will be incorrect. Okay, nitrogen is reduced by hydrogen in the process. Okay, the reaction is N2 plus H2 reversible to NH3. Okay, balance on both sides is a 3H2 plus N2 gives you 2NH3. Okay, nitrogen is reduced by hydrogen. Notice that nitrogen, you add hydrogen, okay, to form NH3. Therefore, okay, addition of hydrogen, gain of hydrogen is reduction. So A is correct. Okay, B, it's not possible to obtain 100% U is also correct because of the reversible sign, meaning that both the forward and the backward reaction takes place at the same time, and you can never have 100% U. Okay, the forward reaction is N2 plus 3H2 to form 2NH3, and the backward reaction is 2NH3 gives you N2 plus 3H2. Because both are ongoing at the same time, you cannot get 100% U. Okay, next, high temperature will increase the U. Okay, that's actually incorrect, so the answer is C. Okay, if you study the graph of the Haber process, okay, look at it carefully, notice that increased temperature, the U will decrease. Okay, last but not least, ion catalyst used to increase the speed. Yes, okay, that's the function of a catalyst, to increase the speed of the reaction. Okay, so you must recall the conditions used for the Haber process is finely powdered iron. Okay, second one is the temperature 450 degrees Celsius. Third one is the pressure 250 atmosphere. Okay, section B. Okay, so when you see this question, first thing you need to understand what they are trying to say. Okay, so they say the flowchart shows how much amount of ethanoic acid. Okay, your ethanoic acid is manufactured. So this is your product, is being manufactured from carbon monoxide and methanol. Okay, ethanoic acid is made from carbon monoxide gas and methanol gas. okay, notice what do you see here? You see a reversible sign, which means it behaves very similarly to Haber process. You will never get, okay, you cannot get 100% yield of ethanoic acid. It's impossible, okay, because both forward and backward reaction are happening at the same time. Okay, notice what they did was the unreacted, okay, they send back to recycle. Okay, the reaction container, okay, 60 atm with catalyst 200 degrees Celsius, quite similar to the Haber process in terms of these three conditions. Okay, part 1, why one volume of carbon monoxide reacts with one volume of methanol? A lot of you wrote because of the mole ratio is 1:1. Yes, that may be true, but it doesn't answer the question. Okay, so the question is basically saying why in this case you can take the mole ratio as the volume ratio. Why? Okay, and the reason is because both of them exist as gases. In fact, yes, both of them exist as gas, and then ethanoic acid is aqueous. Because you have two gases reacting, okay, two gases, you can simply use the volume ratio, okay, as instead of the mole ratio, because mole ratio equals volume ratio, okay, for a gas. If you remember your Avogadro's law states that at 25 degrees Celsius, 1 atm, okay, 1 mole of any gas will occupy 24 dm cube of volume. Okay, however, if you change the temperature and the pressure, they will still occupy the same volume. It's just that it won't be 24, it can be like 23.9, 24.4, okay, so on and so forth. So you must explain that mole ratio is directly proportional to volume of a gas. Okay? Next, 100 cm cube of carbon monoxide, 100 cm cube of methanol are reacted together. If percentage yield is 56%, state the volume of ethanoic acid obtained. Okay, so you must go back to the reaction. If you have 100 cm cube here plus 100 cm cube, how much do you form of ethanoic acid? First thing is you must note that, okay, even assuming 100% yield in the first place, you do not, the volume of the volume of ethanoic acid form is not an addition. Okay, so you have to first use the mole ratio, okay, because it is 1:1:1, which means that 100 cm cube of carbon monoxide will react with 100 cm cube of methanol to produce 100 cm cube of ethanoic acid. And because the yield is 56%, okay, it's 56%, you will just take 56% times the 100% yield of ethanoic acid, which is 100 cm cube, you will get 56 cm cube. Okay, next question. Part B. Table shows percentage yield of ethanoic acid when carbon monoxide and methanol react at different temperatures and pressures. Okay. First, you need to notice that, look, okay, when you see this kind of question, look at the general trend. Okay, so I noticed that for my percentage yield, for my temperatures, they are increasing left to right, pressure is increasing top to bottom. Okay, so because you have two variables changing, okay, it's very difficult to observe any pattern. So first you think you can observe is just have a glance across either side. Okay, so let's say I look at temperature first. I will just look across like this. I'll notice that, okay, as temperature increases, I notice that for each fixed pressure, the yield actually decreases. Can you see? 50 to 43, 32 to 19, 98 to 97 to 95 to 92. Okay, so that's one pattern that I observe. Next, I will observe up to down. Okay, I notice at 100 degrees Celsius, as I increase the pressure, increase from 50 to 80, 94 to 98. Okay, for at 700 degrees Celsius, 19 to 56 to 85 to 92. Okay, you can just do a check for for all columns. You notice that the relationship is the same. Okay, so question part 1, they ask, with reference to information in the table, describe how percentage yield of ethanoic acid changes at a fixed pressure and fixed temperature. Keyword here, fixed temperature and fixed pressure. Which means that if you did not you did not mention about fixed pressure and fixed temperature in your answer, you are already wrong, because there is no exact trend unless you are fixing, okay, one of pressure or temperature. Okay, you have to fix them to observe an accurate trend. Okay, so the first trend is at fixed pressure, yield will decrease as temperature increase. So look at the pressure. As temperature increases, yield will decrease. Okay, next, at fixed temperature, yield of ethanol and acid increases as pressure increases. So I look at the fixed temperature. Okay, as the pressure increase, my yield starts to increase down the column. Okay. Okay, next, maximum yield of ethanol acid in the table occurs at 80 atm and 100 degrees Celsius. So where is that? 80 atm 100 degrees Celsius. So this is the max volume, max yield 98%. Question says suggest why instead I use 60 atm and 200. So where is 60 and 200? 60 and 2 okay, it's not inside the table, but that's the actual temperature and pressure used. So 200 degrees Celsius should be somewhere around here. Okay, in this column, maybe around 93% yield. So some of you said that because it's the highest yield, definitely wrong, because it's clearly not. Okay, so you have to address two parts. You have to address the pressure. Okay, you have to address the pressure firstly, and then the temperature. Okay, temperature is easier, so you just have to say speed of reaction takes place faster at 200 than at 100 because you're comparing these two temperatures. Okay, next, 60 atm versus 80 atm. Okay, a lot of you wrote that at 80 atm is more expensive, it's more costly, but you did not explain why it's more costly. So you have to mention about the cost to maintain the high pressure by equipment. Then only then I'll give you the 1 mark. Okay, you have to talk about the maintenance of the high pressure. Okay, if you get both, you get 2 marks. Okay, next question is about oxidation, your redox question, right? So they tell you copper 1 oxide dissolves in dilute sulfuric acid to produce copper 2 sulfate, copper metal and water. Okay, they gave you the equation. When they give you the equation, you need to make full use of the equation. Okay, so complete the table writing down oxidation states of copper. Okay, oxidation state of copper in Cu2O. Remember, all you need to do is assign a X. Okay, so you know that oxygen is -2 by the rule. Okay, so 2x minus 2 equals 0 because there's no overall for copper 1 oxide, it is neutral. Okay, so 2x equals to 2x equals plus 1. Okay, sorry, plus 2 then plus 1. Okay, remember you must include the sign, okay, whether it's positive or negative. Okay, unless it is 0, then you don't have a sign. Okay, so next, Cu, because it's an element, it is just 0. Okay, CuSO4, what you can do is, you know that SO4 is 2 minus. Okay, or if you want to remember that the S in SO4 2 minus is a +6, also works, but it's easier to just use the charge of sulfate, which is 2 minus, and then the OS is -2. Okay, so to make up to for copper 2 sulfate, you just say X -2 equals 0, X equals +2. Okay, so this is the answer. Okay, alternatively, you already know the name for copper 1 oxide. You can straight away take the OS as +1. Okay, so the Roman numeral is always corresponds to the oxidation state, and you know that metals will always lose electrons to form cations because they have 1 to 3 valence electrons. So in this case, copper will lose 1 electron, so the OS is +1. Okay, so now they ask, in terms of OS, explain why this is redox. You have to make use of this information, which means if over here you already calculated wrong, you will lose marks here. So you need to ensure that you have calculated the OS correctly. Okay, so you can say, okay, remember when you want to write, you always write the element because you're talking about OS. OS pertains to element. Okay, so in this case, which element do we want to use? Obviously copper, because we have been calculating the OS of copper and we realize there are changes. Okay, so you have to state copper in copper 1 oxide, or you can say Cu2O. Okay, and then you mention it is reduced, okay, or oxidized. So in this case, it's reduced to copper. Okay, why? Because the OS, okay, spell out oxidation state, decreases from +1 in Cu2O, okay, +1 in Cu2O to 0 in Cu, 0 in Cu. Okay, remember, decrease in oxidation state is reduction. Okay, next, copper, okay, in copper 1 oxide is also oxidized when OS of copper increases from +1 in Cu2O to +2 in CuSO4. So in this case, they are looking at the reactant copper 2 oxide. Okay, it is firstly reduced to +1, okay, here, to 0 in Cu. So this is a reduction, and then as well as a oxidation from +1 in Cu2O to +2 in CuSO4. Always compare the same element when you want to use OS to talk about reduction or oxidation. So in this case, copper to copper and copper to copper, okay? But in this case, it's a special type of reaction. Notice that the same copper is being both oxidized and reduced to different products, which is your disproportionation reaction. Okay, so one more thing to note from the previous question in part B is that if you mention that copper 1 itself is oxidized or reduced, it's wrong because they are using OS. When you talk about OS, it's always coming back to element. So you have to talk about the element in the compound instead, or in the substance. Okay, so this proportionation, okay, you just need to tell me reaction in which element is both oxidized and reduced at the same time. Okay, add on giving two different products. Okay, because it's not possible to have one product in which the same element is both oxidized and reduced to one product. Okay, you need two different products. Okay, next is the QA portion. Copper 1 oxide, they tell you is a red solid. Describe changes in observations when copper 1 oxide reacts with sulfuric acid. Going back to the equation, okay, look at the states first, because you always want to compare states. Okay, so first, usually you will compare solid and the aqueous states. Okay, so in this case, you see red color, copper 1 oxide, and then changes to copper metal. So copper metal, you can say reddish brown, you can say pink, both are acceptable. So the change is red, okay, red to red brown, okay, or pink. Okay, there's okay, and then the color, okay, the answer is not very showing here. Okay, and then for your aqueous solution, H2SO4 is a acid, is colorless, and then copper 2 sulfate is blue because it contains Cu2 plus ions. Remember from your QA, your light blue or blue is your Cu2 plus. Okay, so the color change for the solution will be colorless to blue or light blue. Okay. Okay, next, the last question. Okay, question 3. Okay, very long. Okay, so you have to really sieve out, pick and choose which information do you think is relevant. Okay, what I recommend is you just do a quick scan of quickly read through first, and then when you read the question, you come back and identify the portion that you want to focus on. Okay, so you just read through. Okay, photochromic lenses are lenses that darken when exposed to UV light. Okay, when it's removed by walking indoors, lens will gradually return to clear state. They are made of substances such as silver chloride. It's transparent to visible light in the absence of UV light. But when exposed to UV ray, silver chloride decomposes to form silver and chlorine atom. So you can start to actually highlight the chemistry portion, right? Okay, so in terms of the substance changing, silver chloride, okay, silver atoms are trapped in spaces between the spaces of materials and causes it to turn dark as shown in reaction 1. Okay, so the symbol is not showing. Okay, so you look at reaction 1, they give you AgCl, okay, will decompose, right? So which part is this? Is this part. Silver chloride decomposes to form silver and chlorine atom. You have silver chloride forming silver and chlorine atom. Okay, and they say, oh, it says reversible. Okay, it's reversible due to the presence of another material present in copper 1 chloride. When it's absent, reaction 1 lessens. Chlorine atom will react with copper 1 chloride to make up for copper 2 chloride. Okay, so chlorine atoms will then reduce, chlorine atom here will then reduce copper 1 chloride back into copper 2 chloride back into copper 1 chloride and silver chloride. Okay, returning back to transparent state. Okay, give the oxidation and reduction half equation for the change that causes the lens to turn dark in reaction 1. Since they already tell you reaction 1, just focus on reaction 1, ignore reaction 2, so focus on this one. Okay, first thing you need to note, okay, these two are arrow signs. Okay, first thing you need to note is oxidation and reduction. What is oxidation and what is reaction? Remember, half equation is always about showing electrons, right? Electrons. So you need to think back for gain in terms of oxidation and reduction in terms of electrons. Okay, gain electrons, it is reduction, and loss of electrons is oxidation. Okay, so I should not see gaining of electrons for reduction and losing. I should not see gaining electron for oxidation and losing electron for reduction. The moment you do that, you will get both wrong because you have mixed up oxidation and reduction. Okay, so next is to identify the half equation. So how do you do that? Okay, you need to split. You need to split the atoms. You need to identify the ions first. Okay, so in this portion, AgCl, you need to note that there's an Ag plus and a Cl minus. Okay, when they are decomposed, they will form Ag and Cl. Right, which that means they are just returning they are no longer transferring their ions. Okay, so you notice that Ag plus has become Ag and Cl minus has become Cl. So now you need to figure out which one is the oxidation, which one is the reduction. Okay, one easy way is to look at OS. So what is the OS of Ag plus? Is a plus 1 to 0 in Ag, minus 1 in Cl, minus 2, 0 in Cl. So this one is obviously, okay, a reduction because decrease in OS. Okay, because the question is asking for half equation, okay, you do not need to show the OS in the answer, but you can use the OS to help you quickly pick out or whether it is oxidation or reduction reaction. Okay, because it's reduction is gain of electron, so you must know that it's a Ag plus E. Okay, and this is your reduction. Okay, that's one easy way using OS to check. Same thing, you know from OS, minus 1 to 1 is a great increase in OS. It is a oxidation. Oxidation means I lose electron. So originally you will put minus here. Okay, it will be a minus. It will be a minus electron on the left hand side, but we bring over, becomes plus E on the right hand side because we do not want to show minus electron. Okay, so these two answers are your answers here. Okay, always use OS to check. It's very easy and fast. Okay, last question. In terms of reference to reaction 2, explain why copper 1 chloride is a reducing agent in terms of the changes in oxidation state. Okay, so reducing agent, what does that mean? Okay, it itself is oxidized. Okay, or you can say that it reduces the other substance. Okay, take note, question 1 in terms of oxidation state, which means if you use hydrogen, oxygen, or electron, you will get 0. Read the question and answer the question. Okay, so with reference to equation reaction 2, look at reaction 2. Okay, one easy way, just assign the OS first. Okay, anyway you assign the OS. So in copper 1 chloride is plus 1. Okay, in Cl is minus 1, chlorine atom is 0, and chlorine atom here is minus 1, and this is copper 2 chloride, so it's plus 2. Okay, so how do you explain that copper 1 chloride is a reducing agent? Okay, you either have to tell me copper 1 chloride it itself is oxidized, therefore it's a reducing agent, or it has reduced chlorine atom, so you choose one. Okay, so if you want to go with the fact that copper 1 chloride, it itself is oxidized, you have to say it itself is oxidized first. And how do you prove it? You look at whatever is relevant. In this case, you see Cl is minus 1 in CuCl, and Cl is also minus 1 in CuCl2. So do not use chlorine. You cannot prove using chlorine, so you have to look at copper. So copper is a plus 1 in CuCl, plus 2 in CuCl2. Therefore, you say OS of copper increases from plus 1 in CuCl to plus 2 in CuCl2. Therefore, you have shown that, okay, it itself is oxidized, and you will get 2 marks already. Alternatively, you can show that chlorine atom has been reduced. Okay, so you have to explain copper 1 chloride has reduces the chlorine atom. How do you show that? You look at the OS of chlorine atom. It has changed from 0 in Cl to -1 in CuCl2. Oxidation state of chlorine decreases from 0 in Cl to -1 in CuCl2. Okay, and that's the end of the paper.